Hi there, here's the Chapter 1 and Chapter 2 notes combined. First we'll start with Chapter 1. The first part of Chapter 1 is talking about classifying data. We have categorical, numerical, nominal, ordinal and discrete and continuous types of data. On page 4 of your textbook, it gives you all the breakdowns of what types of data these are. In categorical data and numerical data, there is one question that has popped up in previous exams, is asking what type of variable is postcodes for houses. So postcodes being a number you think will fall under the numerical value. However, your postcode tells you where you live. So it's a specific location, so it's actually categorical. So that's just one example to have a look at, if you can find on past exams, is household postcodes is not numerical value variable, it is a categorical variable. Moving on, segmented bar graphs. This can be done as a percentage or as a frequency. Just make sure you label what that axis is, because you may lose marks. So what you're doing is just the different types of data you've got, you'll specifically show different segments on the bar chart. Careful once you work out one, make sure that you're then subtracting that from your total and working out each section individually. You need to have a key on the side there and a correct scale. So you can't just say if this is 10 and that value is 40, you can't just have 10 and 40. It needs to be a correct scale, so 10, 20, 30, 40, all the way up to 100. Assessors are really picky on scales. Calculating percentages, that goes along with if you're doing a segmented bar chart using percentages. Bar graphs versus histograms. They look very similar, however they are completely different. Bar graphs we use for categorical data. So if you can see, it's a bar, they're not touching, our categories are down and on the bottom axes, and they're written. Also, make sure that your axes are labeled. Histograms we use for numerical data. This is when you have intervals. So in maybe your frequency table, it's 0 to less than 10, 10 to less than 20, for example. This is how we would display it as an interval on your bottom axes. Once again, those are labeled. You need to make sure you label your axes. The assessors will be very picky again. On your calculators, you can plot your bar charts or your histograms using your CAS calculator. Here's two ways you can do it. You can use a spreadsheet, or you can use the statistics function from the main menu. When you are in statistics, there's this little button once you've plotted your graph that says X, Y, and it's got a little line to find specific values on your bar or on your histogram. I'll revisit this in a minute. Log transformations. This is just something that you would definitely have in your resource booklet. This here is just compare where your values would sit if you needed to do a transformation, and then move them down. So for example, if we had log 10, they won't show it as a 10, or just would say log, and we wanted to find the value of this X value, just where that X is, you would move down, where the Y is, you'd move it, and then we can solve it. So that's just something just to have in your resource booklet. You don't need to know it off your head, but if you can, that's even better. Chapter 2 notes. Every single exam that I've looked at pretty much has a stem and leaf question. It would involve trying to find the median or the mean or the mode, intervals, outliers, all those kind of things. Know how to do stem and leaf plots. There's a couple of bits of information you need to have. You need to have a key, because the key would tell you what the value is. For example, one line 5 is 15. However, it could be one line 5 might be 1.5. Have the key. And it needs to be in size order. So as we can see, 3, 7, 9, 2, 4, these are in size order. A common mistake that assessors actually say is that people would say 7, 3, 9. They're not putting it in size order. Make sure it's in size order. there is we can split our stem and leaf plots into halves or in fifths. If it's halves, as you can see, there's two values, so 0, 0, 1, 1, 2, 2. The first one goes from all the values from 0 to 4, and the second one all the values from 5 to 9. In fifths, as you can see there, we've got 1, 2, 3, 4, 5. We've broken up to 5 segments, and these are going from 0 to 1, 2 to 3, 4 to 5, etc. up to 9. There are back-to-back stem and leaf plots. So back-to-back stem and leaf plots, we might have males and we might have females. It's just a line down here, and the information goes from the middle out to the left in size order as well. Dot plots, very simple. We have scale down the bottom. It needs to be labeled as well, and it's just a circle or a dot for each of those categories, just stacking them up on top of each other. Need to have the correct scale, very, very important. So for all these, we can work out 5-figure summaries, which I'm going to show in a minute. Calculate median, which is the middle value, and quartile 1 or quartile 3 or upper or lower quartile, however you have learnt these. Median position, we can find out its position by the total number of values plus 1 divided by 2. So if we had 10 values, it would be 10 plus 1, which is 11, divided by 2 would be the 5.5 value. That's not the median, it's the position. So very important. If you use this formula, you are finding out the position, not the actual value. So then in your data, which is in size order, you're then finding that position. Now when you're finding your median or your Q1 or your Q3 and it falls in the middle of two numbers, you need to take the average of those two numbers. So for example, this one here, the median's fallen in between 3 and 4. Add 3 and 4 together, divide by 2. Up here, your Q1 and your Q3 have fallen in between two values. Add them together, divide by 2. So be very, very careful. Sometimes your median will be a whole number, or sometimes your median may fall between two numbers. So you just work out the average of those two numbers. 5-figure summary. One of the most valuable pieces of information you can find from data. Use your calculator. So with our calculator, we would go to statistics. You would place in all your values. You go to calc, one variable. Make sure that your list is list 1, where all your information is, and go OK. X with the line on top is your mean. The SX is your standard deviation. Now, if you don't have an SX and you've got something that has an n-1, that's your standard deviation. Not sure why that is. Some calculators have SX and some have this one that's got n-1. The SX is standard deviation, or if you've got the n-1 there, that's your standard deviation. Your 5-figure summary is here. You've got our min value, Q1, our median value, Q3, and our max value there. With that information, you can do so much. It also gives our mode, and then so much further information you don't really need. So our minimum value, Q1, median, Q3, and our max value. You can then draw your box plots straight from that information. Box plots. These are a graphical way of showing all the information. We've got between our min and our maximum value. It breaks it down into quarters. So from the minimum to that first whisker is 25% of our data. From Q1 to our median is another 25%, and so forth. So each one of these sections is worth 25%. Make sure you have a scale. Important. I've gone on that so much already in this information. Scale, scale, scale. So from our 5-figure summary from our calculator, you can quickly find these 5 pieces of information. Know that these are 25%. IQR range, calculating those. Q3 minus 1 is our IQR. Our range is our max minus our min. Calculating outliers. So this is a fence or a barrier. Anything that falls outside the values that you calculate, so anything that falls below the lower fence is an outlier, and anything that falls above the upper fence is an outlier. And there's a really quick way you can show this on your calculator, but you need to be able to show your calculations for calculating if something is or isn't an outlier. So drawing the box plots using our calculator, here's the information here. However, I'll just show you on calculator. We've got our information. If we click on this graph button here, most likely it's going to be scatter, but let's change it to medbox. Tick show outliers, because that's going to actually place your outlier calculation on your graph. Make sure it's the correct list. Frequency is fine for one. Go set, and then click graph. Comes up like this. That dot there is showing our outlier. If there isn't a dot there, that means there's no outliers. So a really quick way you can test to see if information has outliers. How to find what these values are? If you go this XY button up top that I spoke about earlier, it tells you down the bottom here your minimum, and if you just click across, Q1, med, Q3, max, and then, oh sorry, not max, that's that's our fence, or the last data value that falls inside our data, and then our maximum value, which actually is an outlier. So just to clarify that, this line here is the last data point that falls inside our outlier fence. So 27. Our fence would be somewhere here, and our maximum value is now actually classified as our outlier. So if you're drawing this, draw your outlier, put a dot 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 where your fence is, and that's the last data point that falls inside your fence. Types of distributions for histograms and box plots. This information can be found on page 62 of your textbook. So page 62, it just shows here what a symmetric distribution looks like in terms of a histogram and a box plot, positively skewed, for example there, and negatively skewed, and distributions with outliers. So something that you may have in your resource booklet that you can just quickly have a look and reference to if something's positive skewed, negatively skewed. Describing box plots from a distribution template. This is the information they're looking for. So have a read of it. All you need to do is write exactly this if they're asking you to describe a box plot, and just insert where these brackets are is information. For example, what the variable's name is, what type of skew it is, and exact value. So if you could have this in your resource booklet, write out word for word and just only change where the brackets are, the information. Mean and median as a center. This is on page 69 of your textbook. Another thing that you might have, or if you can remember it, don't just put it into your resource booklet if you can't remember it, but choosing what is the better measure of center, where will you use the mean or the median. So if something is symmetric, there's no outliers, we can use mean or median. But if something's clearly skewed and there is outliers, we use the median to indicate the center, because if we have extreme values, average, mean can be really heavily affected. So if something's symmetric, doesn't matter, we can use mean or median, but if it's skewed and or there is outliers, we need to choose median as our choice of center. This question quite often pops up in the multiple choice exam. Once again, I've already spoken about the mean standard deviation using your 5-figure summary on your calculator. Knowing what your calculator is, SX is your standard deviation. If you've got that one that has n-1, use that as your standard deviation. Standard deviation. This is a summary of information about the spread of the data around the mean. So we're looking at the mean. So you've got to have a mean as your middle of your data, and then the standard deviations is how far away particular data points are from our mean. You can quickly calculate something called the Z-score. Z-score is just an approximate amount of standard deviations from your mean. So you have your actual value minus your mean, and you divide it by your standard deviation. You can actually go back by rearranging this formula to work out an actual score if you've been given your Z-score, standard deviation, and your mean. So that's a really quick approximate of working out your standard deviation. Once again, your